In this video we're going to do two things. First of all, we're going to take a look at the new MetroY Pro from Revopoint, but we're not just going to test the scanner. I also wanted to actually give you some practical examples of 3D scanning and show you the kind of projects I use it for, including tangible real-life results. So instead of just scanning a bunch of random stuff, I got a number of little projects prepared, ranging from small to big objects and covering different applications, so you have a better idea of the possibilities and also the limitations of using a 3D scanner. And just to be transparent here, this video is sponsored by Revopoint, but I'm absolutely free to give you my honest opinion here, and I'm going to try to show you the scanning process and the results as clearly as possible, so feel free to mute the video and judge the performance for yourself. So for starters, let's actually unpack this thing. As usual with Revopoint products, the MetroY Pro comes in a really nice carrying case that holds everything securely. I'm always happy to see that they put effort into this part, because it just wouldn't feel right to keep this kind of device in a cardboard box. First of all, we of course have the scanner in here, and you might notice that it actually looks quite similar to the Trackit I tested recently. And that's because these two actually use very similar sensors, and I'll talk a bit more about that towards the end. In the back here we have a port for the USB cable and also a little vent for the internal cooling fan, and then on the other side there's the usual buttons for starting and stopping scans and adjusting exposure. Speaking of cables, one thing that's really cool about the scanner is that you can use it both in wired mode and also completely wireless, depending on the situation. So for wired mode you'll be using this USB-C cable, which gets connected to an additional power supply. Then we have a little tripod for stationary scanning. This is made of solid aluminum, and like the rest, it feels quite well made. And for perhaps the most interesting feature, we got this thing, which is the battery grip. This powers the scanner in wireless mode, and on top here you can install this phone holder and the scanner, so you're completely untethered. We also get a large turntable which can rotate and tilt, and this also has built-in Bluetooth, so it can connect to the scanner and control its movement, which allows you to do fully automatic scans. And then of course we got some marker stickers and the obligatory bust for testing purposes, as well as a calibration plate. I'm gonna go over some of the finer details during scanning, so let's go ahead and start with the first project. This once again has something to do with my bandsaw here. This has a single-phase motor, which means it needs capacitors to start, and that's what's inside this plastic box here. The problem is that some time ago I managed to break this box somehow. I don't remember how exactly, but as you can see, a pretty large chunk broke out of the cover here. I did glue this back in as a quick and dirty fix, but these kinds of repairs never last long in my experience, and I consider this box kind of important because of what's in there. As you can see, we have two pretty sizable capacitors in here, and right where this piece broke off is also where the connection terminal is, and this is something you really don't want to touch by accident or have metal chips fall in, because even when the saw isn't connected to an outlet, those capacitors can still carry a significant charge and give you a nasty shock or potentially cause a fire. So what I want to do is to get rid of this sloppy hot glue fix and 3D scan this whole part so that I can then print a full replacement. If you're familiar with 3D scanning, you know that it's usually necessary to stick these markers onto the object you want to scan, because the scanner needs those to track its position. This can be a little annoying, but I think what many people don't realize is that you actually don't necessarily need markers on your object. As you can see, I simply stuck a whole bunch of markers onto the back side of this cutting mat, so it can now double as my scanning surface. You can use basically anything for this purpose, so a large piece of cardboard would work just as well, and this significantly reduces the need for markers on the object, and in many cases it's going to allow you to scan stuff completely without touching markers, which you'll see in some later scans. In this case I'm still placing a handful of markers on the object just to be safe, but something that also helps a lot is marker objects like these domes here, which you can buy or 3D print. These are super quick to set up and can be reused as much as you want, just like the marker mat. For this first scan I'm going to go with the wireless mode, so I've attached my phone here and then we can just snap on the scanner and connect it. And with that, let's start actually scanning this. Like last time, I'm showing you what I'm doing with the scanner and also a synchronized feed from the scanning software. And as you can see, this scanner is extremely fast at capturing data, as the model here turns from red to this bluish color. This shows you which areas already have sufficient data and where you still need to capture more for a complete scan. The MetroY Pro features a whole bunch of scanning modes, so it's more like a toolkit where you can choose what works best for your purpose. For most of these scans I use the crossed laser line mode, since it's the most versatile, but there's also things like structured light mode or single line mode for special applications. With this being a black object, it's something which a lot of scanners struggle with, because black and shiny objects are generally something you'd need scanning spray for with most cheaper scanners, but the sensors on this are optimized to handle this kind of thing, so it's not an issue at all here. Another benefit of using a scanning mat is that I can actually move the mat around to get to other areas, so I don't have to walk around the object. To the scanner, it makes no difference whether you move the object or the scanner. The only important thing is that the position of your object doesn't change in relation to the markers. So if I move the mat, it's no problem, but if I move the object on the mat, that would probably mess up the tracking. At any point during the scan, you can always hit pause to check out your point cloud. So far, this looks like a pretty complete scan without any obvious gaps. So I'm going to hit complete, and that's going to save our point cloud for later use. And then I can simply go to new scan and we'll do another scan from the other side. In this case, I'm using a little trick by elevating the object a bit, which makes it easier to scan the sides. For most objects, you're generally going to need at least 2 scans in my experience. And for more complex objects, you can combine as many scans as you want. So it's by no means necessary to get a perfect model in one go. And just to be clear here, while it looks like my phone is running the scanning software, it's important to understand that what you're seeing on the phone screen is technically just a screencast from my PC. There are scanners where you only need the phone, but since 3D scanning requires a lot of complex data to be processed in real time, that generally only works for relatively low performance scanners. But a high-end scanner like this one produces so much data that a phone simply wouldn't be able to keep up. So having a fast PC is what enables me to scan with almost 60 frames per second here. I think this side is also looking pretty good now, so I've paused the scan to look at the model, which shows us there's still some yellow areas and some small gaps that could use a bit more work. For that, I can just hit start again from any position I want and pick up right where I left off, because the tracking is really good on this and it always finds its last position again. You can occasionally see a message saying there's not enough markers, which can occur in tracking loss for a few seconds. But that's just the scanner telling you it needs a few more markers in its field of view, and it always recovers once that's the case, so it's nothing to be concerned about. Anyway, the scan now looks pretty good, so I'm going to start finalizing the model. The first step for this is running the fusion command on both models, which interpolates the areas between the points and cleans up some of the noise, and then we can start cutting away everything we don't want in the scan. For most scans, this is a fairly quick process using the various selection tools the software gives you. After that, I'm going to run the cleanup commands. For example, isolation detects and removes points that aren't attached to anything, and then comes my favorite part because it's oddly satisfying, and that is the merge function. We're going to use this to turn our 2 scans into one, and it's generally very good at matching the position of the models you want to merge automatically. So if I'm happy with the alignment it suggests, I can simply hit merge and it will then combine the 2 point clouds. The next step is to turn the point cloud into an actual polygon mesh that can be used by other programs, and while this all might look a bit complicated, it's actually really easy once you understand the principle. I prefer doing these steps manually, but there's also automatic processing available, which does a lot of this stuff for you, but you can generally get better results if you do it by hand. One of the last steps is the fill hole command. This automatically detects areas where the mesh isn't closed and can automatically fill them. This doesn't work well for huge gaps in the scan, but for small holes like these, it usually does a really good job. With all the processing done, I can now export the final model and import it into Fusion. As you can see, it's just kind of floating in space now, but that's easy to deal with because I can just create a few planes by selecting 3 points on the model. So for the first one, I'll pick up the corners here. And if I do the same with another flat surface, I can then use those planes as a reference to align the model to my coordinate system. Before printing this, I want to add something though, and that's just a really simple shape that reinforces the backside and the top by adding a lot more thickness. It's not very pretty, but I consider this a purely functional part, so I really don't care how it looks as long as it works. I then sent that to the printer, and here's what the final result looks like. I did choose to put the supports on the inside, which took a bit more printing time, but that way the rough surface won't be seen later. And as you can see here, the size matches perfectly, and it actually feels a lot more sturdy too, thanks to the support I added. Now I can finally see how fragile my fix actually was, and it really didn't take much to break this off again, so let's hope the replacement fits. I didn't bother cleaning the holes in the model, so I just ran a drill through those and then tried installing it, and as expected it fits perfectly. It might seem like this was a lot of work to fix something relatively mundane, but actually the entire process of scanning this and modifying the model only took me about an hour, and the cost in filament was maybe $2, so I think that's a pretty worthwhile investment. For the next little project, I want to make a custom tool holder for the multi-fix tool post on my lathe here. This is not going to be for cutting tools, but rather to mount a dial indicator. And you can make or buy adapters for that, which fit into the tool holders I already have. These holders are pretty expensive though, and I don't have that many, so I want to utilize those for actual cutting tools. And it's really not necessary for an indicator to have a solid steel holder like this, so I figured why not just print one for this purpose. The issue here is that the geometry of the multifix system is surprisingly complex and I can't be bothered to model this manually, so let's just scan it and see if that approach works. In this case I'm going to use the turntable, which is an absolute lifesaver for scanning smaller objects like this. You can use this in different ways, and I found it's very effective to actually hold the scanner in your hand and move it up and down while the table turns to quickly capture data from a lot of different angles. But you can also have the scanner on its tripod and just sit back, and you can even use the automatic turntable mode where everything is controlled by the software. In this case I use the scanning mode for shiny objects because this is a metallic surface, and I also use the single line mode for some parts, which helps you to scan deep holes or crevices like these slots here. I also used a fairly high scanning resolution to capture maximum detail on those teeth, and like last time, after processing the data I got a really clean model out of this that I can now modify in Fusion to accommodate my indicator. So first I aligned the model like last time, and then I did a little bit of cleanup on those two important holes and also simplified the mesh so we're dealing with less data. Then I cut off the side of the holder that normally holds the tool, because for this purpose I'm really just interested in those teeth that engage with the tool post. And then I modeled this extension here, which my indicator should fit into perfectly. I tried to get that to line up with the original tool holder as well as I could, and then combined that into one model, which can now be sent over to the slicer, and now it's time to print it. So here's the result, which looks pretty promising so far. I just gotta cut a thread up here for the adjustment screw, which is why I printed this hole undersized. And the same goes for the two locating holes here. Printing perfectly accurate holes is usually a bit of a hassle, so I usually print them undersized on purpose, and then I can just run a drill through them later, or in this case a reaming tool. Now it's time to mount the indicator. In this case I was mostly guessing the tolerances, but luckily it fits in there perfectly. You don't have to force it in, but it still sits in there very snug, so there's no movement at all, which is exactly what I wanted. And now for the big moment, let's see if this was all a waste of time or not. I wasn't sure what to expect here, but I think this is a really impressive fit, considering how small the tolerances have to be for these teeth to fit together properly. I haven't done any kind of modifications to the scan to create this fit, except for the stuff I just showed you, so the scanner really is just that accurate. As you can see, this sits on there really tight with zero movement, and I think this is another pretty good example for how 3D scanning things can save you a ton of time you'd otherwise spend measuring and modeling stuff. Next up is a little EDC project I'm working on. I basically want to create a really compact form-fitted case for some important bike tools. These here are most likely not going to be the final tools. For now I'm just going to do more of a proof of concept to see if the idea and the workflow even makes sense. So first we got this tire lever, which is fairly easy to scan, and I'm once again using the turntable here, but in this case I'm using the scanner in stationary mode, which is the most convenient way of scanning because you can just sit back and wait for a minute and repeat this process with the object in multiple positions, which results in a pretty nice model. The next object is a serious challenge for any scanner because it's chromed, so it reflects most of the light back and also has a lot of detail. I don't need every last crevice in here to be perfect though, I really just need the basic outside shape, and for my purpose the model I got out here is perfectly fine. I also want to include one of my favorite pliers in the toolkit, which is this mini version of the Knipex Cobra. I scanned this the same way as the last ones, and I think I used the highest scanning resolution possible here, which on this scanner can be accurate within a few tenths of a millimeter. And considering this is a fairly small object, I'm super impressed with the quality I got here. If we compare this to the real thing, you can see it really captured even the tiniest details. After scanning, I imported the models into Fusion again and aligned them, and also simplified the meshes by a lot so processing doesn't take as long. A detailed model looks nice, but also makes everything a lot slower, so now that I'm done showing off, I really don't need all that detail. Then I just made a simple box to see which workflow might be good for transferring the shapes. If I cut the shapes directly into the box, that unfortunately doesn't make a lot of sense in this case, because they contain hollow parts and are quite complex, which creates all these weird unusable negative spaces. But what I can do is trace the outline very accurately. Now you can do this with a 2D image, which is how I made all of these drawer inserts in another video, but for objects with complex shapes, having the 3D model allows me to also trace an outline from the side now. And if I extrude that into my existing cutout, I can actually make a very nice form-fitted shape that conforms to the tool in multiple dimensions, which is what's going to keep these from bouncing around in the final tool case. Like I said, I'm just experimenting at this point, so this is just a quick and dirty example to show you what's possible, but I think this approach looks quite promising. Now last but not least, I want to try something that I haven't done so far, which is to scan an entire bike frame. As you know, I work with bikes a lot on this channel, and I also often modify existing frames, so quickly getting an accurate model can actually save me a ton of work when planning projects. According to Revopoint, the Metro Y is rated for objects up to about 1 meter in size, and this is actually a fair bit larger, but as you'll see, that's not an issue at all. For this one, I extended my scanning mat with another smaller cutting mat I happen to have. And since it's almost going over the mats on the top and the bottom, I'm also placing a few markers directly on the table there, just to make sure I have enough. Then I can start scanning, and this actually worked way better than I expected. The relatively featureless shape and glossy finish of the tubes here isn't a problem for the scanner at all, and you might also notice I didn't place a single marker on the actual frame here. As I said earlier, for a lot of objects you can get away without touching marker stickers at all once you have a scanning mat and some marker objects. So setting up a scanning environment for a fairly complex object like this can take less than a minute. Once I had one side scanned as well as I could, I flipped the frame over and did the same thing from the other side. And then I ran Fusion on both models as well as the merge command. What's nice is that the entire Revo scan software is set up with a non-destructive workflow, so at any point you can just go back if you don't like a result. In this case I ran the merge command just to see which areas might be missing between the two scans I made, and we can see there's still a gap around the down tube and on the bottom of one of the chainstays. With a uniform object like a tube, I could most likely just close these using the hole filling feature, but I decided to just take 2 more scans and do it properly. In this case I'm scanning selectively, so I'm really just trying to capture the 2 areas that are missing. Since everything else looks fine, I can also just cut off most of the irrelevant areas from these scans, and then I once again merge them together, and the models now perfectly complement each other and our empty areas are filled in. So here's the final model I ended up with, and I think this looks really good. I expected this to be way more of a struggle, but the whole scan took less than an hour, including the post-processing, and as you can see we got every small detail in there. Now modeling a bike frame by hand isn't super complex as long as you're just going by the basic geometry, but things get tricky when you want to measure the actual profile of tubes like these chainstays. This area is the most important part on any bike frame because it determines both the tire clearance as well as the clearance for cranks and chain rings. And thanks to having this model, I can now, for example, easily figure out clearances for different rims and tires without any guesswork. So that was the last project for today, but before we finish this, I think it makes sense to draw a few comparisons between this scanner and the Trackit that I tested recently to give you some perspective. The Trackit, in my opinion, makes the most sense for professional or commercial use. It uses a different tracking technology that actually doesn't require you to use any markers at all, and it delivers amazing scans, but that unfortunately comes with the downside that it costs more than 3 times as much as the MetroY Pro, which puts it way outside of the scope for most hobby users or even small businesses. Now, having used both of these scanners, I can tell you that in terms of the pure scanning performance and in terms of the actual end result, these 2 scanners are surprisingly close to each other. The actual scanning speed, the reliability, the features and the quality of the scans is pretty much on the same level according to my observations, so what it really comes down to is mostly just the whole marker thing. But as I showed you in this video, dealing with markers isn't actually that big of a deal if you're smart about it. So with that in mind, I think the Metro Y is actually a really good deal in terms of overall value. Of course, $1,600 is still steep for a lot of hobbyists, but the non-pro version is almost as good and can be had for around $1,200, which is what many hobbyists nowadays spend on a 3D printer. So high quality 3D scanning is definitely getting a lot more attainable. Personally, I really don't have much to complain about with this scanner, but if I had to name something, it would be that the hardware requirements for the PC you need to run these scanners are scary high. That being said, I actually talked to Revopoint about this, and they told me they're actively working on improving the performance of their software as we speak, and will be releasing an update soon which should make it run much better on slower PCs. So if you're on the fence due to this point, there's a good chance it won't be a problem that much longer, and you might want to check out their social media accounts for the release announcement. Anyway, I hope you got something useful out of this video, and if you're interested in the Metro Y, you can of course find a link in the description. And if you got any questions about the scanner or ideas for other projects, feel free to drop them in the comments. And with that, thanks for watching and see you next time.